Hi to everyone. Can you hear me?
Yes.
Yeah, fine. So I will speak about the thermal comfort indices dataset, and I feeling a little bit unusual because during my experience on ICUEC conference, it's about 16 years. For the first time, I have no word urban in the title of my talk, but I will try to nevertheless to do my best and be interesting. So, what is the motivation for making such big databases? So, of course, and a lot of previous speakers say that the heat waves, then heat waves became more and more dangerous. And this excellent slide by Michael Allen from the first heat wave that was very well described, the heat wave of Chicago 1995. So, and you see the rising of mortality, and especially from this photo from Chicago Tribune, you see the most vulnerable, categories of population is very young, small children and the elder people. So the next event was the Great Russian Heat Waves that kills about 11,000 inhabitants in Moscow, and the total number of increase in mortality was about 64,000 inhabitants in the European part. That is quite similar to the results of the Great European Heat Wave of 2003, that in the whole Europe it was about 65,000, if I'm not mistaken. So that's why, at least we have two ways to improving the scientific progress. The first way, it's more difficult way, it's to making the extremely good research, and you don't know every time that will be in the end. And the second one is creating instruments for all scientific, for all the scientific people for making the progress much more intense. And one of this way is creating in environmental sciences is to creating the new databases for a lot of different values. For a very well-known example is the NCEP car reanalysis that made a lot of for progress for climatology and the meteorology for all around the world. So you see that it was maybe the first example, and in biometeorology they have the excellent work of Claudia Di Napoli and co-authors. It's the creating of first biometeorological reanalysis is for Era 5 heat, the global UTCI reanalysis from derived from the data of the Era 5. So it you see in Era 5 heat, but there are some little problems due to the using only one thermal comfort indices. What do we need to use thermal comfort reanalysis? For example, it's for tourism and leisure. It's the identification of new territories for targeted health restorations, the epidemiological studies, because potential predictors of the excess mortality, the environmental studies, and the social studies and urban planning, because the modification of thermal stress areas for different type of social vulnerable populations. And from my point of view, we need to use multiple indices because, for example, if we performed such study about the growing of the relative risk of mortality during the different heat waves in the southern Russia, for it was about 5 different cities. So, and we found that the best predictor is the physiologically equivalent temperature. Not you see any types of the real temperature and the humidity index, the mean values and the maximum values. That's why we decided to create 3 years ago, during the COVID outbreak. We have a time for some thinking about science. And we decided to create the thermal comfort data by multiple indices, and we name it NETCID, North Eurasian Thermal Comfort Indices Dataset. It's the derived data from the error interim reanalysis. It's the with horizontal resolution of 0.75 degrees with time resolution of 3 hours for the period from the 79 to 2018. So we have chosen two indices for extreme heat, the humidex and the heat index. The one called index, wind chill temperature, and two indexes based on the modeling of the thermal stress for organism is the physiological equivalent temperature and universal thermal comfort indices. So we have some formulas for the relatively simple indices, and also the RAND for the complicated indices. We ran the model of Matsarakis and Meyer, and also now it's maintained by Dominic Freundlich. It's a Raymond model because we have an idea to do it as the best way. So, of course, we have some hierarchy of the data structure, so separation by different indices by time of the year of the diurnal statistics, and I will show you some examples. It's, from my point of view, it's a bit interesting because we know that the most coldest part of the Eurasia and the northern Eurasia especially is the Republic of Yakutia, is the eastern part of the Russian Federation, so you can see during the winter. But the most discomfort area is not here. It's near the Arctic board, so it's due to the very intensive wind conditions, according to UTCI and the PAT. According to the summer situations, were quite a bit homogeneous. It's interesting when during the winter, for different grades of the cold stress, especially, the different indices show the heterogeneity of the special heterogeneity of indices. So, for example, for extreme cold stress, the good choice will be UTCI, but for the high cold stress, the wind chill will also work. The same thing for the summer. So we see that the heat index or humidex are not explained so very well in homogeneity for the whole northern Eurasia during the summer. And the complex indices PET and QCI can improve such kind of data. And our favorite metric, so the repeatability of the stress-free days. So not about the extreme conditions, but what will happen with the days without stress conditions. And so we see it's was surprising for me that the main area will be on the east, on the southeast of the northern Eurasia. So you see the island Hokkaido, the China, the southeast of Russia, but also the some places near the board of the Biscay Bay, near the Black Sea, and so on. What's about the trends? We are always interested about the trends, and you see the linear trend coefficients for repeatability of the days with the high heat stress during summer. So not a lot of indices can show us clearly. For example, you see the humidex is especially for especially warm and humid conditions didn't show that for North Eurasia it's well. And for physiological equivalent temperature and TCI, it's work very nice, and you see this the increasing linear coefficient of trend, especially on the southwestern part, so especially in the near the Black Sea and all the southern Europe, eastern, western, and the central also. And now on time, my favorite. So linear trend coefficients for repeatability of the days without cold. Where will be these places, then the comfort will rise. And you see, it's the whole Scandinavia. It's near the border of the Baltic Sea, of the Norwegian Sea, and on the top, on the north of Western Europe, and also according to the stress-free days are minimizing on the south region. So we also make some representation of very well-known heat waves for 2000, 2003, and 2018. Also, we performed the comparison with the verified heat data sets for three cities, for Moscow, Paris, and the Yakutsk. And it's from which picture it can be seen that it works in one direction. So I will go to the final results. So the NETCID thermal comfort database is ready, is freely available for any of your research. And we decided to supplement this time series of these 5 indices for more than 8,000 of the pre-calculated statistical parameters characterizing climatology for the thermal stress conditions. So all the statistics is already there. So enjoy. Thanks a lot.
We did a very wide view and different index like PT and we can see it. So